So now that we've talked a little bit about how the enemy and asteroid class is going to work, let's go ahead and start off by creating the enemy class, and from there we'll move into the asteroid class. And by the end of this video, we shall see some asteroids on the screen that we can collide with.
Alright, well let's turn our attention over to the game folder, and we'll add in a new item. This item will be our enemy class. The first thing I'll do inside of enemy is clean up the sub namespace and add in a using for Microsoft XNA framework. So we'll grab our XNA framework, and that will take care of our using statements. The next thing to address is, what class does enemy extend? Well, it extends the ship class. And inside of enemy, we are going to have precisely one field. This field is going to be the static list of enemies. This is the list we've been talking about back from the whiteboard.
Right, and this is going to be very important for projectiles, so that basically there's a collision list of good projectiles that have come from the player, so that we can simply tell what items that we can collide with.
Exactly. Anytime we need to tell an object that it collides with enemies, it is this list that we'll be looking back to.
Nice.
So let's drop it in place. It will be a public static list. This list will be of type GameNode. We'll call the list enemies and initialize it here by constructing a new list of game nodes. And once again, I'll stress the fact that it has to be of type GameNode, not of type enemy. We want to keep it generic enough that all the way back in GameNode, the collision code works correctly with these kinds of lists.
That's right.
Moving on from here, we can drop in the constructor for enemy. This will be a public constructor, so public enemy, and we'll need to take in a sprite sheet, which we will call simply sprite sheet. And we'll make sure we have our call to the base constructor, and we will feed in our sprite sheet. Now, we do need to put a little bit of code into this. We need to make sure that as enemies are instantiated, they get added to the static enemies list. So we'll begin by taking our enemies list and adding this new instance into it. And then we'll set up our collision list. That means set up the collision list for us as an enemy to point at the player ships. The reason I'm doing this inside of the base enemy class is so that all subsequent classes that derive from enemy will automatically be set up to collide with the player. Because generally all enemy style objects need to be hostile to the player, such that if the player crashes into him, damage is taken.
That's right.
So by doing this here, we don't have to worry about setting up the collision list every single time different kinds of enemies are created. So we'll set our own collision list to reference the player ship's collision list. So that is found within player ship, and we're looking at the player ship's static list.
And through inheritance, we know that that collision list is coming from our game node.
Exactly, because the ship is a game node, the enemy is a ship, and therefore the enemy inherits from game node.
That's right.
Alright, moving on from here, we've got a handful of methods that we need to override. One of these from node and a couple from game node. We'll begin by overriding the remove method. So if we look through here, we've got remove. The reason we're going to be overriding remove is we want to make sure that whenever this enemy is removed, it also gets removed from the enemies list and keeps that collision list up to date. So we'll look into our enemies list and tell it to remove the current instance. Alright, the next method we need to address is the update method. The reason we're going to be looking into update is we are going to have enemies removed if they fall off of the screen. So we're going to put in an override to update, and inside of update we're going to run the check that is found back in game node that will get the current screen bounds, take into account how wide, or take into account the overall dimensions of this enemy, and make sure that it's visibly off screen, then remove it. And we can do that by calling upon the remove off screen method. Moving on from here, there's one more method that we need to address inside of enemy, and that is exactly what happens when an enemy collides with something else, collides with some other node. Well, what's going to happen is the enemy is going to cause an amount of damage to the node that it collided with, and it is also going to take damage itself. So we're going to override the collide method, and this is how we get notified of the fact that a collision occurred. I'm going to wipe out the call to base.collide, because if you remember back to the game node, the implementation there is blank, so there's nothing to really call upon. What we're going to need to do is we're going to set up a scenario, since we don't have any kind of damage property. We're not explicitly told how damaging this enemy is when we collide into it. The way I'm going to handle damage exchange is I'm going to set it up so that the enemy's health is applied as damage to the node that it collided with, and the enemy takes an amount of damage equal to the node that was collided with.
So let's say that we just ran into a player ship, and the player ship happens to have 75 health points. That means we will have just received 75 points of damage, where if we had a health of, let's say, 50, that means the player would have just received damage of 50.
Exactly.
So it's a swap, basically.
Yeah, it's basically a swap. So let's say if you had if the player has 75 health, let's give an example of Asteroid. We're going to be setting Asteroid's health to 50.
Okay.
So if you have 75 health on the ship, 50 health on the Asteroid, the two collide into each other, well, the ship's going to win. It has more health.
Mm-hmm.
But what will happen then is the ship's health will be taken down to 25.
That's right.
And the Asteroid's health is technically going to be taken down to, I guess, negative 25.
Which means, yeah, it's below 0
and gets destroyed.
That's right.
So the way we're going to accomplish the swap is we will need to, let's say, buffer the incoming node health, because we're about to take away from that node health, and we need to have access to the original to apply damage to ourselves as an enemy. So we'll make an integer that we're going to call node health, and we'll set it equal to the incoming node's health.
And keep in mind who the incoming node is. That is the person that we just collided with. And this being an asteroid, let's just say we've just collided with a player.
Exactly. Since we are looking at ourselves as an enemy from this point, just knowing how the Spacefighter game is going to work, we'll know that, well, enemies collide with players.
That's right. So that node reference is...
Exactly. The terminology is kept general, because if we were looking at this from the ship's point of view or a projectile's point of view, then the incoming node could be enemies.
Right.
It's left very generic because there's nothing to say that you couldn't have one type of enemy collide with another type of enemy. The system is left open for that. You would just need the adequate collision lists to handle that. So now that we've got our original node health saved, we can go and perform the damage swap, where we'll damage node and this enemy. So the way we'll perform damage is we'll take our node and we'll cause it to take damage, and the amount of damage will be equal to this enemy's health. Then we'll turn around and damage this enemy, so we'll say this dot take damage, and we'll feed in a value of the original node health. And that should accomplish the damage exchange, and with that, that's all of the code necessary for enemy.
Very simple, very straightforward.
I will build briefly, make sure that there's no errors, and then we can turn our attention over to the Asteroid class. So I'll go back over to game, we'll add in a new item, and this item will be Asteroid. Now, before we get started on any of Asteroid's members, I'm going to switch over to the config class, and I'm going to drop in a configuration parameter for the amount of health that asteroids start out with. So I'll jump in here right below the asteroid sprite sheet, and I'll make a public static integer value. We'll call this value asteroid health, which we will set to a value of 50. Now back in Asteroid, we can begin setting up our implementation. For that, I'll begin with a subnamespace, dropping that back, and we can probably just leave the using statements alone. I think all of the stuff inside of Asteroid is going to be very simple. The first thing to address with Asteroid is to make sure that it extends enemy. Then inside of Asteroid, we'll set up our public constructor, and we'll also set our health from within the constructor. So we'll have a public Asteroid, public constructor, taking in a sprite sheet, which we'll simply call sprite sheet. We'll make sure we have our call to base, feeding in sprite sheet, and we'll drop in an implementation or some additional code into this constructor where we set our asteroid's health. So this asteroid.health will be equal to config.asteroid.health. And with that, that's it. That's the asteroid class.
Pretty straightforward.
So now we can jump into game for a minute, and we'll create an asteroid inside of begin run, and we can see what happens with it on screen and see how it interacts with the player ship. So over here in game, I'm going to scroll up a little bit so we can see begin run, and then I'm going to jump in just after we have spawned the ship, and I'm going to make an asteroid local variable. And we can call this variable asteroid as well. And we'll instantiate a new asteroid. Asteroid being a node is going to require a sprite sheet. We'll get the sprite sheet from config.asteroid sprite sheet. Now we'll turn around and set up a few of the fields of the asteroid. We'll set it up so that's positioned positioned in the center of the screen horizontally, but at the very top just off screen vertically. So we'll take our asteroid and we'll set its position value to be a new vector 2, and that vector 2's x is going to be our screen width divided by 2. So we'll look into config and grab screen width, divide that by 2. Then to position the asteroid just off the top of the screen, we'll look at the value for our origin and y and use that as an offset to move up. So we'll take a negative asteroid dot sprite dot origin dot y. Once we're positioned on the screen, we need to set up how fast this asteroid is going to move. So we'll set our asteroid's speed field, and we'll set it to a value of 2. And finally, we need to set up the direction that our asteroid moves in, and I'll have the asteroid simply move straight down towards the player. So we'll make our asteroid's direction set to a new vector 2 of 0 in x and 1 in y. Now, if everything builds and runs correctly, we should see an asteroid appear off the top center of the screen and move towards the player. So if we run, we can't control the player because I had left it as player 4, but we do see the asteroid. The asteroid hits the player ship and disappears.
Nice.
Let me very briefly here change our player index back to 1 for the initial player. Make it easier to control with the keyboard. But as you can see, we hit, the asteroid goes away. Now at the moment there is not much information given as to why the asteroid disappeared. We also notice that we have no damage effects being applied and no explosion spawn. Because
no texture flick or anything like that.
Exactly. But we did see that the asteroid did in fact disappear. Mm-hmm. And that makes sense if you think about it. If we have a ship starting at 100 health, the asteroid with 50, then we should have a ship with 50 health left over and the asteroid simply gets destroyed.
Another thing we can test real quick is run it one more time and just get out of its way and make sure it smoothly goes off the bottom of the screen.
That's true, because this is one other chance we get to look at our remove off screen and see it doesn't disappear too early. So that means our remove off screen functionality back in game node should be working well.
Excellent.
The one thing I'll point out that this doesn't prove yet is whether or not it disappears at all. Technically, if it was never removed, you'd still see it slide off screen. We'll get around to proving that once we put in a simple information display for our game, and that information display will include the number of nodes and the health of all of the players. But that's for an upcoming video. One last thing I want to do in this video is spawn more asteroids so that we can run into enough asteroids to actually see the ship get taken out and make sure that that works properly. In order to accomplish multiple asteroids, I'm simply going to use the same block of code inside of a loop and then just modify some of the position and speed information.
Which this should allow us to actually get killed, because when we run into one of these asteroids, we take 50 points of damage. And are we starting out at 100?
We are. Back in config, as a matter of fact, we can point to it right here. Ship health starts at 100.
Nice. So we hit that first guy, it knocks us down to 50. We hit the second guy, and it knocks us down to 0.
But what should happen, since these values are equal, then after we take the first asteroid hit, we're down to 50 ourselves.
Right.
So the second asteroid, we now have equal health. So what should happen? Since we do an equal amount of damage to each other, taking each other down to 0, so both should get destroyed.
Very nice. And then we could even play with that so that we offset our player's health to begin with and watch the asteroid eliminate us but continue moving because it didn't quite receive enough damage.
We can up the asteroid's damage by just 1 point, so it just barely wins the damage exchange.
Cool. So yeah, several things we can test here with multiple asteroids.
So what I'm going to do is I'm going to set up a for loop to give us 8 asteroids. So the length here I'm simply going to hard code in as 8, and then we can jump in below all of our code to put the ending bracket for the for loop in place, and maybe take a few lines out and neaten everything up. Now one thing I do want to change is the positioning and the speed. So we have maybe 2 different rows of speed and the asteroid's positioned across the X direction.
Okay.
The way I'll do that is I'll set our position in X equal to some multiple of the I index variable. So let's do something like maybe 96 units in between each asteroid. So I times 96. And I'm also going to offset an additional 32 pixels to make sure that the leftmost asteroid is completely on screen. We'll leave all of the asteroids spawning off screen in Y. Now for the speed, instead of having them all move at the same speed, let's have maybe every other asteroid move faster. So let's take I modulus 2 and offset by 1. So what this should do is every other asteroid will have 1. So basically the if we looked at these
1, 2.
Exactly. Overall,
because
1, 2.
I mod 2 is going to give us the value between 0 and 1.
Yeah, so 0 and 1, 0 and 1. Then we add 1 to make sure that all of them move. So we either have 1 or 2 in speed.
Precisely.
Then direction will be left alone and point straight down the screen. Now if we run, we have a lot of asteroids. So here we go. First asteroid hits, the asteroid disappears. Second asteroid, both the asteroid and the ship get destroyed.
Nice.
So now we can change the balance a little bit by going into config, and if we change our asteroid health to 51, well, the first hit is still going to destroy the asteroid because 100 health is greater than 51, but on the second asteroid hit, the ship gets destroyed and the asteroid continues to run. If we were looking into that asteroid, we would see that it had 1 health left.
Right. Excellent. I do believe that's everything that we set out to do in this particular video. Is there anything else that you would like to add?
No, I think that covers it. We've got enemy established, where enemies are set up with proper collision for colliding with players, and they're set up to cause a damage exchange when they hit their collidable nodes. And then we took a look at using that enemy to create an asteroid and placed some asteroids on the screen.
Excellent. Okay, well, with that is going to conclude this video. Thanks a lot.